Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Apache Solr Operator is a Kubernetes native solution for deploying and managing Apache Solr clusters. It automates complex tasks like setting up ZooKeeper, managing persistent volumes, and scaling nodes. This video is designed for intermediate developers and DevOps engineers who want to leverage Solr in cloud-native environments. Apache Solr is a powerful open-source search platform built on Apache Lucene. It enables full-text search, hit highlighting, faceted search, and real-time indexing. It's widely used in e-commerce, content management, and enterprise search applications. Kubernetes operators are software extensions that use custom resource definitions to manage applications and their components. They automate tasks like installation, upgrades, and failure recovery. Operators bring application-specific operational knowledge directly into Kubernetes. Deploying Solr manually in Kubernetes involves complex configurations. The Solr operator abstracts these complexities by automating setup, scaling, and management. It also integrates seamlessly with Helm, Prometheus, and other Kubernetes native tools. The Solr operator introduces two key custom resource definitions: SolrCloud for managing clusters and SolrBackup for handling backups. The operator controller watches these resources and ensures the cluster behaves as expected. The SolrCloud CRD lets you define the desired state of your Solr cluster. You can specify the number of nodes, shards, replicas, and even the version of Solr to use. It also manages the ZooKeeper ensemble required for coordination. SolrBackup CRD enables automated backups of your Solr data. You can schedule backups, define retention policies, and choose storage backends like S3 or GCS. Restoring data is just as simple with a few YAML edits. The architecture of a Solr operator deployment includes the operator controller, which watches CRDs, SolrCloud pods that run the actual search engine, a ZooKeeper ensemble for coordination, and persistent volumes for data durability. Deploying a Solr cluster starts by applying a SolrCloud custom resource. The operator detects this and begins provisioning resources like pods, services, and persistent volumes. Once deployed, the cluster is ready for indexing and search operations and can be monitored via Prometheus. Scaling the Solr cluster is as simple as updating the replica count in the SolrCloud CRD. The operator handles shard rebalancing and resource allocation automatically, ensuring optimal performance during traffic spikes. Backups are scheduled using the SolrBackup CRD and stored in cloud storage. In case of failure, you can restore the entire cluster or specific collections with a simple command. This makes disaster recovery seamless and efficient. Solr operator integrates with Prometheus to expose key metrics like query latency, indexing rate, and memory usage. These metrics can be visualized in Grafana dashboards and used to trigger alerts when thresholds are crossed. Security is a top priority. The operator supports TLS encryption for internode communication, integrates with authentication providers, and enforces Kubernetes RBAC to control access to Solr resources. In benchmark tests, Solr operator managed clusters have shown impressive performance metrics. Query latencies remain under 100 ms, indexing throughput reaches 10,000 documents per second, and clusters can scale up to 100 nodes without degradation. A major e-commerce platform uses Solr operator to power its product search. With millions of products indexed and real-time inventory updates, users can perform faceted searches with filters like price, brand, and category, all powered by Solr. Enterprises use Solr Operator to build centralized document search systems. These systems support role-based access control, ensuring only authorized users can access sensitive documents. Employees can search across departments and file types seamlessly. Solr Operator also powers log analytics systems. With real-time ingestion and query-based alerting, teams can detect anomalies and troubleshoot issues faster. Integration with SIEM tools like Splunk or ELK enhances observability. While Elasticsearch is popular for analytics, Solr excels in structured search and is easier to manage with the operator. Both are valid choices depending on your use case, but Solr Operator gives you more control over deployment and scaling. The Solr Operator simplifies deployment and management, but it requires a solid understanding of Kubernetes. It's best suited for teams building cloud-native search platforms that demand scalability and automation. To get started locally, install Kind or Minikube, deploy the Solr Operator using Helm, and apply a sample SolrCloud custom resource. This gives you a fully functional Solr cluster in minutes. In production, ensure persistent volumes are backed up, deploy across multiple zones for high availability, and set up monitoring and alerting with Prometheus and Grafana. Helm charts make deploying and upgrading the Solr Operator easy. Customize values.yaml to match your environment, and use Helm's rollback feature to revert changes if needed. The operator supports rolling updates and rollback capabilities, ensuring zero downtime upgrades. This makes it ideal for production environments where uptime is critical. When troubleshooting, start by checking operator logs, validating your CRD configurations, and inspecting pod statuses. Tools like Kubectl Describe and Kubectl Logs are invaluable for debugging. The Solr Operator community is active on GitHub, Slack, and mailing lists. Comprehensive documentation and tutorials help you get up and running quickly. The roadmap includes multi-cluster support, enhanced backup strategies, and AI-powered query optimization. These features will make Solr even more powerful for enterprise use cases. Apache Solr Operator is a game-changer for deploying and managing Solr in Kubernetes. It simplifies complex tasks, enhances scalability, and integrates with modern tooling. Start experimenting today to unlock the full potential of your search infrastructure. Thanks for watching. If you found this tutorial helpful, hit that like button, subscribe for more DevOps and cloud tutorials, and drop your questions or feedback in the comments below. See you in the next one. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.